This is AB Calculus, free response, problem 3, and this is from the 2015 AB Calculus test, and problem number 2. Problems number 1 and 2 will be calculator problems. And so let's just get with it. Let f and g be the functions defined by f of x equals 1 plus x plus e to the power of x squared minus 2x. So since it's really not too legible here, I'm just gonna write it out here. We have f of x equals 1 plus x plus e to the power of x squared minus 2x. Okay, so there we have f of x, and g of x is x to the 4th power minus 6.5 x squared plus 6x plus 2. And so we have areas R and S. Here's area R. I'm labeling here larger, and area S. And I don't know if you could see this, but we are going, this point over here at the far right is 2, 4. So to find the part A, find the sum of the areas of regions R and S. Well, the thing we're going to need to find first of all is this intersection point here. And the best way I know to do that is to go to our graphic calculator and get a graph page. So here we get a graph page, and we're going to put these two functions in place. We have f of x equals 1 plus x plus e to the power of x squared minus 2x, and we have this function graphed. You see it right there. And we have the next one, which is tab. We have x to the power of 4 minus 6.5x squared plus 6x plus 2 and we see these areas. Okay, and this one in the middle, and I'm going to zoom in here a little bit. Go to window zoom. Go. There we go. Window zoom. Zoom the settings. We'll go between maybe 0 and 5. And then come down here and go Y minimum 0 to 5. It should get us a tighter look at this thing, which we have at this point. Okay, so we can see this right here. So we're interested in this intersection point. To find it, we're going to go to Menu, Analyze Graph, Intersection. It says left bound, right bound, and here we have these values 1.03, 2.4. Well, one thing we're going to need for the calculator section of our test is significant digits. So if we just go and put our hand over this 1.03 and then go activate the plus sign, we should be getting some additional significant digits here. Let's get over here. It's easier to do with your calculator. So there we have that one, the x value, and now we go to the y one. Again, easier to do with your own calculator. So let's say 1.03 1.03283, and I'm going to tell you why I have that many significant figures here. So we have 1.03283, and then our y value is 2.4011. And I'm going to get into why I chose so many significant figures out here, but let's go ahead and write this out. Again, we want these two areas, and the top area, this curve, is going to be this g of x function. So I'll put g of x up here, and the one down here will be f of x. And so what we want for region R, we want to find the sum of these two regions. We're going to have to find the area, I'll just say is A, is going to be the integral from 0 to 1.03283, and we're going to have this g of x minus f of x dx. So g of x minus f of x dx. And then we're going to have area S, which is going to be, we'll add this and we'll say, okay, this is going to be between 1.03283 and 2. And in this instance, we're going to have f of x minus g of x dx. Okay. And then below that we can write this out. Area is equal to, just rewriting this, 1.03283. We have g of x, which is x to the fourth, minus 6.5 x squared plus 6x plus 2. And we're going to subtract out f of x, which is 1 plus x plus e to the power of x squared minus 2x and dx. And to that we're going to add the integral from 1.03283 to 2. We're going to have f of x minus g of x. And so we have 1 plus x plus e to the power of x squared minus 2x. X squared, not too legible. Okay, and we're going to subtract out g of x, which is x to the fourth power minus 6.5 x squared plus 6x plus 2 dx. And then we can just put this in our TANSPIRE calculator. And in this instance, what we're going to do is go to get a calculator page, Control I, and we get the calculator page. We are in radians. Not that that matters, we don't have a sine function here now. We're going to take an integral And to do that, we use the hotkeys. We're going to press the Shift key and the plus sign, and we're going to go from 0 to 1.03283, and we come over to the right here. We're going to have, I'm going to put f of x which is, or rather g of x, which is x to the fourth power, minus 6.5 x squared plus 6x plus 2. Okay, and we're going to come outside and subtract the other function, f of x, which is 1 plus x plus e to the power of x squared minus 2x. Okay, and then we come over here, and I think that's all right, dx, and then we go to the, make sure we're to the right, and then we add. Okay, we're going to bring out the integral again, hotkey Shift plus sign. We're going to go 1.03283 all the way up to 2, and then we're going to come over here to open two sets of parentheses, the first one of which is going to be this 1 plus x plus e to the x squared minus 2x. Okay, and that is all nicely parenthesized, and we're going to subtract out the other function, which is going to be g of x, which is x to the fourth power minus 6.5x squared plus 6x plus 2 and we put x over here, and we should get it all right here, 2.00435. So 2.00435, and round it off to 3 significant digits after decimal point, we're going to have 2.004. So either one of these answers will be just fine. If you have multiple decimal points beyond 3, they'll just look at the first 3. So they'll consider the first 3 decimal places or the first 3 properly rounded to that place. All right, next, part B. Region S is the base of a solid whose conic sections perpendicular to the x-axis are squares. Find the volume of the solid. So here we are up at S, and I'm going to go ahead and just kind of sketch that in. We're going to have a squares coming out here, perpendicular, and so we have bigger squares, littler squares as we go on, and so you're going to have a three-dimensional shape built from these cross sections that are compiling upon each other there. So what we're going to do is, first of all, take the equation for a area of a square, and that is going to be A. You get a smaller there A is equal to the side times the side, or S squared. So we take this distance between the top function, the bottom function, g of x, excuse me, f of x in this case, minus g of x. We're going to find that base of the square. So let's go ahead and write out what that looks like. The volume is going to be equal to the cross-sectional area. We're looking at area S, so we're going to go from 1.03283 to 2, and then we're going to have f of x minus g of x, and we're going to square all that, dx. So that's going to be it if we write it out. So to write this all out, I'm going to put it down below here, leave, I hope, enough room. We have integral from 1.03283 to 2, and we're going to have f of x, which is 1 plus x plus e to the x squared minus 2x minus g of x, which is x to the fourth power minus 6.5 x squared plus 6x plus 2, and we square all of that dx. And that's going to be what it is. So again, we go back to our calculator and we get our integral symbol the same way, the shift hotkey shift plus. So we're going to go from 1.03283 to 2. Now might be as good a time as any to bring up why all these significant digits here. Well, the reason is that we're going to want to have our final answer according to AP standards rounded off correctly to at least 3 places. And what happens is that when you're talking about a preliminary answer, which this 1.03283 is, we're going to compound our errors the farther we're off. So the idea is getting as many digits, maybe 5 or so, that will make this work such that you're not going to be in danger of having rounding problems. I don't know how much that makes sense, but it will help you with your accuracy. So we come here, close the parentheses here, we're going to subtract out, open parentheses, this x to the fourth power minus 6.5 x squared plus 6x plus 2. We're going to come out here outside of this and square outside of it, and then go to dx, and we get 1.28316. And to 3 significant figures after decimal point, we'll have 1.283. Either of these answers will get you full credit from your AP scoring. Next, we're going to look at part C. Let h be the vertical distance between the graphs of f and g in region S. Find the rate at which h changes with respect to y to x when x equals 1.8. And so here we are, we have region S going back here, so let's go ahead and kind of sketch what that looks like. So region S, we have the exponential curve here, and we have our polynomial function. So here's region S, and 1.8 is going to be about right here, just before 2. This is 2 comma 4. So 1.8 is going to find itself right over here. So if I just draw a little vertical line for x equals 1.8. So you're comparing these two slopes is what it looks like. Anyway, h is going to be the difference between those two. So let's write that out. We have h of x equals f of x minus g of x, because this top curve here is f of x, this bottom one here is g of x. So h prime of x is going to be equal to f prime of x minus g prime of x. If you don't have a multiplication or division or some other operation, you're just going to add or subtract. It'll be fine like this. So what we want at the rate at which h changes, well, we're going to have h prime of 1.8 is going to be equal to f prime of 1.8 minus g prime of 1.8. Okay, and just to remember what our f and g functions are, we have f of x is equal to 1 plus x plus e to the power of x squared minus 2x, and g of x is equal to x to the fourth power minus 6.5 x squared plus 6x plus 2. And so we can find out what f prime of 1.8 is, and we could also find what g prime of 1.8 is. Let's go figure that in the calculator. So now, previously we've been using the hotkeys to find a definite integral. We're going to now find derivative point. Do that. Instead of pressing shift plus sign, we're going to press shift and the minus sign. So we have d dx, and we're going to just put in here the first function, which is 1 plus x plus e to the power of x squared minus 2x, and we come over to the right here and we're going to evaluate. Now to evaluate, we're going to get a little vertical line segment here that will sum this up. So we press control and the equal sign, and we'll use this little vertical line here, and we're going to say when x is equal to, so we just put x equals 1.8. And so we get 2.11628. And we're going to do similarly here for g prime of 1.8. So we press shift, minus sign, d dx, and we put in this case, x to the fourth power minus 6.5 x squared plus 6x plus 2. And again, to evaluate, we're going to press control equal sign and get this little vertical line segment, and then x equals 1.8. And so we have 5.928. Now, not a whole lot of significant figures here. And to find some more significant figures, we can press Control A and S and print that out. Sometimes that'll work. I didn't get any more significant figures. No, so we can't. 5.928. We'll just live with that. 5.928. I did this in another calculator before, and I got 5.92801, so that's very close. And just subtracting these, if we have f prime of 1.8 minus g prime of 1.8, we're going to have our answer. And so we go to our calculator again, we put in 2.1628 and subtract from that 5.928, so we get negative 3.81172, which would be rounded to 3 decimal places after the 3 places after decimal point, 3.87 and 3.87, and this 3.812 is what it should be. 3.8117. I got that wrong. Okay, which rounds to negative 3.81, and this 17 rounds up to a 2, so either of these would be just fine. Anyway, this is a nice problem using the hotkeys for both integrating and finding the derivative of the point. Good luck in your studies, and thanks for viewing.